So good day everyone. We are group 4 that will be presenting the topic measurement of length, area, speed, and time. So to start with, here is Rosette Bartolome that will be discussing length.
I'm here to share some knowledge about length. So we all know naman kung ano yung length and lagi natin siyang ginagamit to get the distance or size ng object. The first definition of length, as I said, next slide, it is used for identifying the size of an object or distance from one point to another. The word length comes from Middle English lengthy and from Old English lengo, which means property of being long or extended in one direction. The metric system of measuring length was developed in France and is now used by about 95% of the world's population. Based on the metric system, the standard unit of length and commonly used is a kilometer, centimeter, and meter, and we can convert a meter into various units like millimeter, centimeter, and kilometer. Centimeters and millimeters help measure smaller lengths, and meters and kilometers help measure larger lengths like distance. For example, based on the picture, the length of the pencil can be calculated in centimeters or inches using ruler, while kilometers can measure the distance between two buildings or places. According to the length conversion chart, the different units of length and their equivalents are given in the figure. Conversion of these units is done using the given formula. Additionally, in the customary system, inches, feet, yards, and miles are used as the unit of the length. The relation between the customary units is also given in the figure. How to use it? Susundan mo lang yung mga araw. Halimbawa, you want to convert kilometer to meter, you have to multiply it by 1,000. But if you want to convert meter to kilometer, you have to divide it by 1,000 and so on. Same din ang procedure sa customary system. Next. So if nalilito on how to use the given figure kanina, we can use this table na madalas naman ginagamit ng karamihan to identify its length. Next slide. Sige pa. So let's have a sample problem. Basahin ko. A 57-foot wood is cut into two pieces. One piece is 3 feet less than twice the length of the other. What is the length of the longer piece of the wood? The first step that we have to do is to identify what important pieces of information are given to us in the problem. Sinabi sa problem ang total length ng wood, which is 57 feet long. It cut into two pieces daw at ang isang piece ay 3 feet less than twice the length of the other piece. So let's call it a second piece, and the other one is first piece, which represent the variable x. Note that the measurement of the first piece is currently unknown. Since the second piece is 3 feet less than twice the length of the first piece, then it can be algebraically expressed as 2x minus 3. So we have total length na 57, first piece na x, which is unknown, and second piece is 2x minus 3. And now we can find the measurements for both pieces. So yung solution niya is x plus quantity 2x minus 3 is equal to 57. Distribute yung x and is equals to 57. And then 57 plus 3 magiging 16 divided by 3, magiging x natin is 20 feet. Ito yung first piece. So going back to our problem, it asks us for the measurement of the longer piece, but ang alam lang natin is yung sukat ng first piece, which is 20 feet long. In order to determine which one is longer, we use the value of x to also find the length of the second piece. So therefore, 2x minus 3 substitute yung value na x na 20, ang makukuha nating sagot is 37 feet. And now we can identify which one is longer, and that is the second piece. Next slide. So ito naman yung mga instrument na paano ma-measure yung mga length. So first is ruler. The first tool that can be used to measure length is ruler. This type of measuring instrument is probably the most common type and the type that you will often encounter first. A ruler can be made of metal, wood, or plastic and has a linear measurement markings. Next one is tape measure. It is a tape that contains a unit of length that is usually used by tailors to measure parts of the consumer's body and made of flexible and smooth material to be able to reach hidden body parts. So next one is roll meters. It is also called meter or handyman meter. It is also one of the building tools that commonly used. These measuring instruments are usually made of thin, flexible metal that can be rolled up. Usually, mga roll meters is equipped with two units of measurements, namely centimeters and inches. Next one. So, the next one is caliper. Measuring tools for length include rulers, tape measures, and micrometers, screw gauge, but the tool that is the most precise is this Vernier caliper. And this measuring tool is used to measure the thickness ng paper, steel plate, or other metal plates. To understand how it works, I prepared a video from YouTube so we can fully understand the caliper.
Hi, I'm Bob Welds, and this is how to read a metric vernier caliper. There are different kinds of vernier scales designed to do different jobs, but they all work pretty much the same way. Today, we're going to look at a metric vernier designed to measure to the nearest 1/50th of a millimeter. That is 0.02 millimeters. See how 1 divided by 50 equals 0.02? Now, the first thing we're going to measure with our vernier caliper is nothing. That's right, we'll measure 0. It may sound like a silly thing to do, but we're going to do it for a couple of reasons. Let's do it and you'll see what I mean. You see, when the calipers are fully closed, measuring 0 width, you can see the places where you can take measurements. These surfaces are where the two parts of the calipers line up. You'll also notice that there are gaps in a couple of places on the calipers. These are not places to take measurements, so don't mess up by putting something in one of those gaps. Now, with the calipers closed, you can see where you're supposed to read the main scale. There are two scales on a vernier caliper, the main scale and the vernier scale. I'm going to erase the vernier scale and let you just look at the main scale first. You see, the 0 mark points to the place where you're supposed to read the main scale. Right now, it points to 0. Do you see that? Good. Let's read the main scale first. It's super easy. I'll close the calipers on this workpiece and we'll see what the main scale says. These marks represent whole millimeters. So the reading is 1, 2, 3, 4, 5, 5 millimeters. Just be sure to look at the 0 mark and not at this part. That's a common mistake and it'll give you the wrong reading. So the reading is 5 millimeters. That's pretty easy, right? Before we move on to the vernier scale, let me show you what it's going to tell us, okay? Let's say when we looked at the main scale, the reading wasn't right on the mark like it was last time. Let's say it looked like this. See how the mark is between 5 and 6 millimeters? It looks like it's a little beyond halfway. You see, the vernier scale is going to tell us almost exactly how far over the mark is. Okay, you're ready to see the vernier scale, but I'm only going to draw the main part of it first. Now, you see the marks number from 0 to 10. Each of these marks represents a tenth of a millimeter. They're going to tell us the tenths of a millimeter, and here's how they work. Look carefully, and you will notice that one of the marks on the vernier scale lines up better with the main scale marks than the others. Which one looks like it lines up best to you? I'll zoom in and let you look. Let me show you a hint about where to look on the vernier scale to see where the marks line up. You see how our pointer was a little more than halfway between marks? That means the vernier scale will line up a little past halfway. Now, do you see the mark that lines up better than the rest? It looks like the 7 is lining up. The 7 means 0.7 millimeters. But this caliper can measure even more accurately than that. I'll redraw all the marks and let you look again. Now, see that the mark next to the 7 lines up best. But what is the value of that mark? Remember how this caliper had a label that said 0.02 on it? That is what each mark is, 0.02 millimeters. Let's count up on the vernier scale to be sure we've got it. This 6 would be 0.60, the next mark 0.62, then 0.64, 0.66, 0.68, 0.70, then 0.72. The reading is 5.72 millimeters. Pretty neat, huh? I'm going to let you try a few. We're going to start off easy. I'm going to draw a caliper that only reads to the nearest tenth of a millimeter, just to be sure you're with me. I'm going to show you the overall picture first, then zoom in to let you see the vernier better. Okay? When you see Sparky's pause the video and write down what you think the reading is. The reading is 16.2 millimeters. Let me step you through it just in case you missed something. Here are the whole millimeters from the main scale, 10, 11, 12, 13, 14, 15, 16. Okay, and you see how the reading is just past the 16 mark? So we'll look to the front of the vernier scale for where the marks line up. And there it is, at the 0.2 mark. So the reading is 16.2 millimeters. Got it? Okay, let's go for broke and see if we can read the full 0.02 millimeter resolution. Ready for this one? Again, I'll show the whole caliper, then zoom in to let you see the vernier better. Here we go. Pause the video and write down your answer. Now, I know this is hard, so before I give the answer, I'm going to point to the place where the vernier lines up. Does that help? Take a minute and check your answer and be sure it's correct. The reading is 19.16 millimeters. Okay, let's try another one. This time I won't give any hints, but I will zoom way in so you can see the calipers really well. If you get this one, you pretty much know what's going on. Pause the video and make sure you can read the whole millimeters. Did you say 12 millimeters? Okay, let's do the hard part and read the vernier scale. I'll zoom in and let you take a closer look. But first, remember the trick? See how the reading is beyond halfway between the marks? That means we need to look on the high side of the vernier scale. I'll slide the view down there and let you look. Now here we go. Pause the video and look carefully. The mark that lines up best is here. Now, what number is that? This is the 0.7 mark. So 0.7246. The answer is 12.76. That's about all the time we have for now. Vernier calipers are hard to read, but with a little practice, I'm sure you'll be able to do it without too much trouble. I'm Bob Welds, and these are Weld Notes.
So, next slide. So, ito naman po yung micrometer. So, micrometer, another instrument used to measure length is the micrometer screw gauge or micrometer. It is uses a smaller calibrated screw that is turned left or right to measure small length. The screw is adjusted according to the size ng item being measured. This object can measure with accuracy 10 times more detailed than a caliper. So to understand how it works, I also prepared a video from YouTube.
Hi, I'm Bob Welds, and this is how to read a metric micrometer. A micrometer is used to take very precise measurements. There are different kinds of micrometers: inside micrometers, outside, depth micrometers, inch micrometers. Just look them up on Wikipedia. But here I have a metric one. This one measures to the nearest 0.01 millimeters. It says so right here. As you turn the knurls, the measuring parts open up. These are called the spindle and the anvil. The spindle moves, the anvil does not. Now to get down to the business of reading this thing, let's take a close look at what's called the barrel scale. I'll have Sparky, my dog, help me out. He's a pointer. You read the barrel scale by looking at the edge of the part that turns. This part's called the thimble. You begin by looking at these marks. You'll notice there are two sets of marks and a line. The marks above the line are millimeters. The marks below the line are half millimeters. Let's stop here a minute and be sure you're with me. What do you think the barrel scale is showing right now? Hit the pause button and think about it. If you said 12 millimeters, you were right. If you didn't, well, there's more to life than being right all the time. Well, let's take a closer look. See, 10, 10 and a half, 11, 11 and a half, 12. Here, let's try another one. Pause the video and think about this one. Do you see it reads 14 millimeters? Good, let's move on. Let's try another one. Now this one's trickier. Pause it for a minute and see if you can figure out what the reading is. Did you say 11 and a half millimeters? See how there's a half mark showing? That counts as a half millimeter. Great. You've got the barrel scale down. Remember that we said this mic would measure down to the nearest 1/100th of a millimeter? Well, here's what that would look like on the barrel. They don't really make marks this small because no one would be able to see them to read them. Obviously, there has to be a better way. Remember that each mark on the barrel is equal to 1/2 millimeter. Another way to think of a half is by saying 0.5. Another way is by saying 0.50 or 0.50. Now, let's put 50 marks on the thimble. As we turn it, the thimble can count from 1 to 50 for us. That means that each mark on the thimble is equal to 0.01 millimeters. Now let's put all this together and try to figure out what this micrometer is reading. First, the barrel scale, 10, 11, 12. So it's 12 millimeters plus something. The something comes from the thimble scale. Let's zoom in. 0.30, 0.31, 0.32, 0.33. So the reading is 12.33 millimeters. Now here's one for you to try. Now it's trickier. Notice the half mark is showing on the barrel scale. Let's see if you can figure out what to do with that. Did you get 11.72? If so, you're really getting this. If not, you might have missed the half millimeter mark. Let me show you. Okay, first look at the barrel. 10, 10 and a half, 11, 11 and a half. Now, write that down. Now, look at the thimble. 0.20, 0.21, 0.22. Now, write that down. Now, add them together and you get 11.72 millimeters. Okay, there's just one more small concept and we'll be done. What if one of the marks is just barely showing? Do you count it? Is it ready to be used? Here is the trick. Don't look at the mark to find out whether the mark is showing or not. Look at the thimble. You need to know if a new mark is starting or if an old mark is ending. In this example, look at how big the number on the thimble is. It's showing about 0.47 millimeters. That's a big number for the thimble. Remember, the scale only goes up to 49. Since the scale is nearing the end, it's ending, and so you don't count a mark that's barely showing. The trick is to find which side of the zero you're working on. If you're not yet to zero, it's not yet a mark. Okay, I've moved the micrometer just a little bit. Now, the mark is ready to be counted, Because the thimble scale is starting. You see that the numbers on the thimble are small because the zero just passed by. This means that the mark is ready to be counted. Okay, so that's pretty much it. There are some micrometers that can measure even more accurately than this. They have a thing called a vernier scale on them. I can show you how to read those another time if you want. Just let me know. But for now, this should get you started. Thanks for watching. I'm Bob Welds, and these are Weld Notes.
The next one is speed. By definition, speed is the distance traveled per unit of time. It is how fast an object is moving. Speed is the scalar quantity that is the magnitude of the velocity vector. It doesn't have a direction. Higher speed means an object is moving faster. Lower speed means it is moving slower. If it is not moving at all, it has a zero speed. The formula for speed is S equals d over t, where S equals speed, d equals distance, and t equals the time. Conversion per unit of speed. 1 meter per second is equal to 3.6 kilometer per hour and equals to 2.237 miles per hour and 1.94 knot and 3.28 feet per second. Conversion formula for a unit of speed. Kilometer per hour to meter per second. It is simply 1 km over 1 kilometer per hour times 1,000 meter over 1 hour times 1 hour over 60 minutes times 1 minute over 60 seconds. And per meter per second to kilometer per hour, it is just a vice versa. Next slide, please. For miles per hour to and miles per hour to
In
meter
this
per
video,
second.
we're gonna talk
1 miles per hour times 1.609 kilometer over 1 miles times 1,000 meter over 1 km times 1 hour over 60 minutes times 1 minute over 60 seconds. Next slide, please. Instruments in measuring speed. First is the speedometer, the most common one. We easily notice on the dashboard. This is the most bolded instrument panel that we easily notice on the dashboard. This measuring tool is installed directly in the system. It gives a real-time reading of the car speed. Same thing happened to other transportation as well, such as bus, truck, bike, motorcycles, etc.
Speedometers help tell your speed while driving and calculates the miles driven. It's connected to a display that is usually located right on the dash in front of the steering wheel. Hello, my name is Charles, and in this episode of Proctor Car Tips, we'll talk about the two types of speedometers that help display that speed and briefly discuss the speedometer displays found in vehicles today. Mechanical speedometers have been around since the 1900s. These type of speedometers use analog devices that attach a drive cable from the transmission directly to the dial on your speedometer. They are often called eddy current speedometers because they use magnetic currents to find out your car's speed by measuring how fast the speedometer cable rotates while attached to the drive shaft. The other type of speedometer is the electronic speedometer that uses speed sensors instead of a physical drive cable to compute the vehicle's speed. Electronic speedometers are quickly replacing the older mechanical ones. Analog dial speedometer displays are still very common in cars today. These type of displays are very basic and show a physical gauge dial moving up and down to show you the speed of your car. Analog displays can still receive the speed from electronic speedometers. In some vehicles, the speed is shown on an LED digital display. This allows for more features to be shown on the display, such as navigation information, driving range, or even Bluetooth audio information. Some cars even have a mix of both digital displays and analog displays. I hope you learned some new things in this episode of Proctor Car Tips. Again, my name is Charles, and if you have any questions, please ask them in the comments below, and like and subscribe to our channel to see more videos just like this one.
Second one is the tachometer, or mas kilala natin sa tawag na RPM. Is a device to measure the angular speed. This measuring device is commonly used to measure machine speed.
Hi, I'm Katie here with your Galco TV Tech Tip. In motor drive applications, a tachometer device is essentially a small DC motor. The tachometer is designed to produce an analog voltage directly proportional to the rotational speed of its shaft. The shaft of the tachometer is typically coupled to the shaft of a larger DC motor. A drive motor will then read the tachometer's voltage and use it as speed feedback. Tachometer feedback significantly improves the speed regulation of a motor and drive system. It is important to not confuse tachogenerators with tachometers, as they are both related to rotational speed measurement, but are very different in both form and function. Stay tuned to Galco TV for more tech tips. Make sure to check out our other videos and be sure to like, comment, and subscribe.
Third one is radar. It empowers the use of radio waves to measure the speed of a moving object. It does not only calculate speed, but also the range and angle. This instrument is so common in aircraft and ships.
Hello! Hear that? That's the sound of my voice traveling through the air, hitting that mountain over there, and traveling back to me. And the time it takes between you shouting hello and when your ears hear is determined by the distance between you and whatever your voice is bouncing off of. Okay, sounds pretty simple, right? Well, that's exactly how echo radars work. This episode of Test Tube 101 is brought to you by the United States Air Force. An echo radar emits a sound wave and then waits for the echo to come back to its receiver. By timing the returning echo, you can work out exactly where another object is. And when using multiple receivers positioned at different angles, it can determine the basic size of an object that the sound waves have bounced off of. But if we add an additional layer, we move into Doppler radars. Doppler radars emit a radio wave too, but also keep track of the radio wave's phase. Basically, its shape, position, and form. When the radio wave returns, it's measured again to check for any changes in its phase. If the frequency came back shifted negative, the object it bounced off of is likely moving away from the radar, and if the frequency came back positive, that object is headed toward the radar. Speed can be determined by the amount of shift that takes place in the radio wave. And this technology is used every day by the United States airmen who go above and beyond to break barriers both professionally and personally every day. Oh, and ever wonder what radar stands for? Well, it's an acronym for radio detection and ranging. Makes sense. Well, there you have it. And if you enjoyed this video, you may also like this one about how our two ears hear in 3 dimensions.
So if a sound hits your left ear slightly before your right ear with minimal reflections, your brain will tell you that the sound came from the left of your face.
Fourth one is the LiDAR. It stands for light detection and ranging. This device utilizes 600 to 1000 nanometer laser light, measuring the distance via the reflecting time of the laser that reverts back to the receiver.
LiDAR, light detection and ranging. LiDAR is a remote sensing method that uses laser to measure elevation like ground, forest, and buildings. LiDAR uses ultraviolet, visible, or near infrared source to sense objects. Light energy emitted by LiDAR system is known as pulse. Light reflected from ground or object is known as return. This means the LiDAR system sends a pulse of light and it waits for the pulse to return. It measures how long it takes for the emitted pulse to return back to the sensor. In the end, it gets a variable distance of the objects. Actually, this is how LiDAR got its name: light detection and ranging. Like sonar uses sound waves to map things, radar uses radio waves, a LiDAR on the other hand uses light sent out from a laser. A LiDAR unit scans the ground from side to side as the plane flies. Because of this, it covers a larger area. While some pulses will be directly at nadir or a straight line, most pulses travel at an angle. Airplanes, unmanned aerial vehicles, and helicopters are the most commonly used platforms for acquiring LiDAR data over broad areas. There are different ways to collect data using LiDAR: from ground, from plane, or from satellite. There are three types of LiDAR. Topographic LiDAR. It maps the land typically using near-infrared light. Bathymetric LiDAR. It uses water-penetrating green light to measure seafloor and riverbed elevations. Terrestrial LiDAR for mapping buildings, natural features, and trees at ground level. It is also very useful for 3D models of heritage sites. How does a light detection and ranging system work? There are four parts of an airborne LiDAR. LiDAR sensors scan the ground from side to side with a pulsed laser beam as the plane flies. The sensor has a detector for sensing the returns from objects. GPS receivers track the altitude and location of the airplane. These variables are important in attaining accurate terrain elevation values. Inertial Measurement Units, or IMU, tracks the orientation and speed of the airplane as it flies. Elevation calculation use orientation to accurately determine the actual position of the pulse on the ground. Computers record all of the height information as the LiDAR scans the surface. These four parts of LiDAR system work together to produce highly accurate and usable results. LiDAR is used for wide area mapping, coastal changes, floodplain mapping, and for engineering applications like for mapping bridges and roads. LiDAR system allows us to examine both natural and man-made environments with accuracy, precision, and flexibility. In the next part of the LiDAR story, we talk about the various uses of LiDAR in detail. Keep watching.
Next one is anemometer. This is the device that is generally found in a weather station. It functions to measure the wind speed along with the wind direction.
This morning we have a weather question coming from Zephyr Hills High School, our 10 News School of the Week, powered by Duke Energy Florida.
Hello, my name is Rachel Bissett. I'm a freshman at Zephyr Hills High School, and my question is, how do you measure wind speeds?
Rachel, good question. You know, something that we've been talking a lot about is wind speeds, especially with the wildfires out in California this week. They had wind gusts out there propelling those fires over 70 miles per hour. So how do we measure wind speeds? Maybe not as easy as you might think. We use this device right here called a cup anemometer, and named rightfully so because of the cups that are around the frame here of this anemometer. There's a 4-cup anemometer like we have here, and there's also a 3-cup anemometer, both used for different things, but basically get the same result. And they're great because they can measure the speed of the wind regardless of what direction it's coming from. That wind speed is caught up in the concave side of the cup there in the anemometer. So when the wind begins to blow, it will spin the anemometer. So how does that work? Well, a little math for you this morning. I know it's early, 5:26 right now, but if we find the circumference of the anemometer, which we'll call C, and you are able to count, which this is all done by a computer within the anemometer itself, if you count the number of rotations that occur within a minute, and then you multiply that by the circumference, you're able to get, if you measure it in inches, the inches that it goes every minute, you're able to then calculate that to be the miles per hour that the wind is blowing. Good question, Rachel.
Lastly, we have the liquid flow meter. As the name suggests, it functions to calculate the speed of water that flows in a particular pipe. There are a lot of flow meter types based on how they work. And for the sample problem, a man walks 20 kilometers in 4 hours. Find his speed. For the solution, distance covered is equals to 20 kilometers. Time taken equals 4 hours. We know that the speed equals distance over the time. So input the values 20 kilometers over 4 hours. Therefore, the speed is equals to 5 kilometers per hour. Another sample problem is, John drove for 3 hours at a rate of 50 miles per hour and for 2 hours at 60 miles per hour. What was his average speed for the whole journey? The solution is, formula for the distance. First, we need to get the distance. The formula for distance is equals to rate times time. Distance total equals 50 times 3 plus 60 times 2 equals 270. Time total is equals to 3 hours plus 2 hours equals to 5 hours. Using the formula of speed, 270 miles over 5 hours equals 54 miles per hour.
So next is time. Time is the change or the interval over which change occurs. Time is also the measure of non-stop consistent change in the surroundings, usually from a specific viewpoint. SI unit for time is the second, abbreviated as S. Here, sa 60 seconds, merong 1 minute. And sa 1 hour, merong 60 minutes. And 1 day, merong 24 hours and so on. To convert yung time, makikita dun sa baba na para ma-convert yung week into days, we just have to multiply it to 7. And to convert naman days to weeks, we just have to divide it by 7. Next slide po. So, brief history. Ancient Babylonians discovered sexagesimal system, a numeral system with 60 as base. So, bakit nga ba may 60 seconds sa 1 minute and may 60 minutes sa 1 hour? It is because sa mga na-discover nung ancient Babylonians, yung mga early humans. As you can see sa picture, ginamit nila yung joints nila sa 4 fingers nila sa left hand, which is equal to 12, and their other hand, multiply naman with their 5 fingers doon, and it will be equal to 60. Ancient Egyptians devised a system of dividing the day into 24 hours or 2 sections of 12. Here po, as you can see sa picture, dinivide ng mga ancient Egyptians yung isang whole day into 24 divisions. Sa normal day, merong 10 hours sa umaga, 1 hour for dawn, and then 1 hour for twilight. And meron namang 12 hours para sa gabi. Pero nagvavary siya tuwing summer and winter. Tuwing summer, mas mahaba yung day, and tuwing winter, mas mahaba yung night time ng 2 hours. Sundial consisted of a vertical stick or pillar, and the length of the shadow it cast gave an indication of time of the day. So, ito yung ginamit ng mga ancient Egyptians na tool to measure yung time na ginamit nila doon sa system na yung kanina, yung device nila. So, nag-work to pag naglalagay ng stick doon sa hole, doon sa top part, and madedetermine yung time kung saan tatama yung shadow na nagawa ng stick. Kapag sinisinagan siya ng araw, and pag nasisinagan naman ng moon sa gabi. Ancient Egyptians also used water clocks, an ancient device for measuring time by the gradual flow of water. So, 12 basins yung ginagamit dito to determine time kung what na nga ba. So, basically, merong basin na nakasahod sa water clock, and every time na mapupuno na yung basin, it means 1 hour na yung nakalipas. And papalitan siya ulit ng panibago hanggang mapuno lahat ng 12 basins. And it simply means half na ng araw yung nakalipas. Candle clock were used by the ancient Japanese, Chinese, and Europeans. So, ito yung tin candle with consistently space marking that when burned, indicates the passage of periods of time. So, dito naman sa candle clock, merong lines na depicting yung time sa likod, yung mismong pinagtatayuan ng kandila. So, it means habang nagme-melt yung kandila, makikita sa height niya kung anong oras na nga ba nung araw. Next po. Romans called the 12 hours before midday as ante-meridiem and 12 hours after midday as post-meridiem. So, Romans ngayon nagpangalan sa umaga and ng AM and PM sa gabi. So, meridiem came from the Latin word meriges, which means midday, and the ante means before and post means after. Hourglass were used in medieval Europe, utilizing the concept of water clock. And here po, makikita natin yung another tool, and tinatawag natin tong hourglass. So, yung concept niya, galing to dun sa concept nga ng water clock. So, ito yung common or aware tayo na nag-exist and ginagamit pa niya siya until today. In 14th century Europe, first mechanical clocks were invented and became the standard timekeeping device. So, nung time na to, yung church lang yung may afford na magkaroon ng mechanical clock. So, every time na magre-ring yung clock, meaning nun is 1 hour na yung nakalipas. During 1800s, universal time system was proposed wherein Earth was divided longitudinally into 24 parts. Itong divisions na nakikita natin sa picture dun sa baba, meaning nun is magkakaiba ng time zone yun, yung mga bansa na yun. Yung East, 1 hour yung added for each time zone nila, while yung mga country na nasa West, 1 hour yung subtracted sa time zone nila. Like for example, noon or 12 noon sa London, sa New York, -5 or 7 a.m. Babylonians' 7 days of the week consist of 6 work days and 1 holiday. So, bakit nga ba may 7 days sa isang week? Ito nga, yung mga ancient Babylonians, na-observe nila na 28 times yung pag-orbit ng moon sa Earth. But unfortunately, hindi divisible yung 28 sa favorite digit nila na 6. So, ang ginawa nila, dinivide nila yung 28 sa 4. And it is equal to 7. So, doon nakuha yung reason kung bakit nga ba merong 7 days in a week. So, here's a picture. Yung mga Babylonians kasi, meron silang tinatawag na 7 heavenly bodies. So, these heavenly bodies, naka-arrange yan in descending order. Yung mga nauuna, ay yung mga heavenly bodies na mabilis yung movement, and binase nila yun sa appearance nun sa sky. So, yung mga next rows dito, basis naman yung mga gods and goddesses ng Roman, Germanic, and Nordic. So, instrument in measuring time. So, of course, clock. Ito yung a mechanical clock or electrical device for measuring time, indicating hours, minutes, and sometimes seconds, typically by hands on a round dial or by displayed figures. Next po. Ito naman yung mga types to ng mga clock. So, analog clock. So, ito yung makikita natin na merong tatlong hand. Yung shorter one or yung dinadepict niya. Yung long pero yung thick, minutes, and yung long pero thin, ayun yung sa seconds. Digital clock. So, dito sa clock na to, dinidisplay lang naman niya yung time by numerical digits rather dun sa kanina, dun sa analog clock. Electronic word clock. So, ang ginagamit naman dito is, kumbaga parang ini-spell or by sentences na yung makikita sa screen. And yun nga, dinidepict niya yung time. Auditory clock. So, ang gamit naman dito is recording ng human voice or computer-generated voice to tell time. Tactile clocks. So, ang gumagamit nito is yung merong mga imperfect vision or mga blind. So, makikita yung sa picture na merong braille, and in that way, matutulungan sila or mas makikita or malalaman nila kung anong time na nga ba ng araw. Multi-display clocks. So, nakikita naman sa picture, kumbaga, common to sa airport, meron din sa mga hotel, nakikita yung different time zones ng iba't ibang bansa or lugar.
And lastly, for area po. So, yung area hindi naman na siya bago sa pandinig natin, especially sa atin as ME. So, in geometry, the area can be defined as the space occupied by a flat shape or the surface of an object. The origin of the word area is from area in Latin, meaning a vacant piece of level ground. The area of a figure is the number of unit squares that cover the surface of a closed figure. So, yung unit na ginagamit sa area is meters squared, square feet, square inches, para sa mga pag-unit analysis natin. So, ito yung mga basic formulae ng mga areas from square hanggang sa kite, na sa atin, yung madalas na ginagamit natin is pagkuha ng area ng cylinders, diba? Which is pi over 4 times diameter squared. So, here is a small game lang. So, kung sa tingin nyo kaya nyo, pwede nyo naman i-pause and try nyo i-solve. Pero ito na yung answer niya. It is 85 centimeters squared. So, ang una natin gagawin, hatiin natin sa dalawa. Since it is in irregular shape, pwede nating hatiin sa dalawa to. Pwedeng parehong tig-rectangle, or yung isang way is hatiin natin by 5 by 5 and then 15 by 4. The same way, 85 centimeters squared pa rin naman yung lalabas. So, punta naman tayo sa instruments measuring the area. So, measuring area is essential for many situations in the physical sciences, engineering, construction, and more. To measure an area in a precise manner, requires the use of appropriate measurement tools, which can be found in many homes and construction sites, as well as more complex tools used specifically for specialized functions. So, ayun nga, um, as we all know, nami-measure lang natin yung area sa pamamagitan ng pag-measure din ng length or sa pagkuha ng area as na may gamit na formula. Pero dito, di-discuss natin ano-ano ba yung instruments na ginagamit directly para makuha agad yung area. So first is theodolite. Theodolite is an instrument of measuring both vertical and horizontal areas and angles in conjunction with triangulation. And this triangulation associated with geometry and trigonometry, it is the process of establishing the location of a point by measuring angles to it from several other points on a fixed line. So theodolites are useful in mapping, surveying, and land assessment. So kung ma-observe natin, kapag magpapa-estimate tayo, kapag magpapa-survey tayo ng lupa, theodolite agad yung makikita natin kinakabit sa lupa. Yun yung, tatlong paa, and then makikita natin parang camera. So meron akong short clip dito na ito yung kadalasang nagiging mistake ng mga Pilipino kapag nakakita tayo ng theodolite.
Wala lang palabas. Ano channel yan? Kaya. Pelikula? Kaya. Piolo yun eh. Piolo yun oh. Kaya sino kalab TV Piolo dun? Sino kalab TV? Tangina mo, sino kalab TV Piolo? Hindi na ka pa kinakausap dyan eh.
So ayun, kung makikita natin dito sa YouTube, balik ko lang. Ay, hindi na pala babalik. Yung kanina, yung ginamit na camera, yun yung theodolite na kadalasan nami-mistake ng mga Pilipino as a camera or parang may tinetape na movie or film, di ba? So punta naman tayo sa classification of theodolites. So first is yung repeating theodolite. This design facilitates horizontal angles to be remade any number of times and added directly on the instrument circles. This type of instruments is restricted for locations where the support is not steady or area for using other such instrument is limited. So ginagamit yung repeating theodolite kapag, for example, magsusukat tayo ng lupa sa mga burol. Diba? As may imagine naman natin as may perspective tayo. Kunwari, in a landscape, hindi pantay-pantay yung lupa doon. Kumbaga, uka-uka sa malayo, di ba? So, para masukat, para ma-estimate natin yung lupa na yon, gagamit tayo ng repeating theodolite wherein ulit-ulit siyang ginagawa. Paikot-ikot na ginagawa yan. Ito makikita naman natin sa figure na it is in circular shape. So, paikot-ikot yan, mini-measure hanggang sa makuha yung accurate and less yung discrepancy nung mismong sukat na lupa. Susunod is directional theodolite. Angles are obtained by deducting the first direction reading from the second direction reading. This reads directions rather than angles. The repeating instrument has no minor motion. So, unlike kanina sa repeating, itong directional theodolite, sinusukat niya yung direction rather than angles. So last is electrical digital theodolite. Naturally interprets and records horizontal and vertical angles. Eliminates the standard reading of scales on graduated circles. So unlike din dun sa dalawang nabanggit, ito electronic na siya. It means that mas malilesen na yung error, mas malilesen na yung discrepancy kasi it has its own calculator na. Kumbaga, makikita na agad dito yung sukat ng angle or sukat ng direction. So, to understand paano ba gamitin yung theodolite, here is a short video.
The University of Kansas is pleased to present the Civil Engineering 240 video tutorial series, How to Use a Digital Theodolite. The digital theodolite is a common surveyor's tool frequently used for topographic surveying. The instrument is capable of finding both horizontal and vertical angles, and when combined with stadia techniques, can be used to calculate horizontal distances and differential elevations. For this tutorial, we're going to determine the horizontal angle by repetition between the two red lines you see on the screen on the Learned Hall front lawn, the angle A, B, C. The survey team begins by locating the vertex of the angle to be determined. In this case, it's marked with a yellow traverse cap. The survey team then proceeds to place the tripod directly over the traverse cap, securing each leg firmly into the ground. The team then carefully removes the digital theodolite from the case and places it atop the tripod, securing the bolt firmly into the base of the instrument. The instrument should be at approximately eye level so that no one has to squat too low or stand on their tippy toes to be able to see through the instrument. Adjust the tripod height as necessary. Once the height of the tripod has been made comfortable for the team, it is important to make sure that the instrument is directly over the traverse cap. To do this, place the line of the plumb bob through the hook in the bolt of the tripod. Then gently extend the plumb bob line down towards the top of the traverse cap. Observe the location of the tip of the plumb bob. If the tip of the plumb bob lines up directly with the center of the traverse cap, you're done. If not, adjust the theodolite's location on the top of the tripod accordingly until the tip of the plumb bob is directly centered on top of the traverse cap. Next, ensure the instrument is level by adjusting the 3 leveling screws on the tribby arc at the base of the theodolite. Ensure that the bubble is at the center of the circle on the level. To verify that the vertical axis of the digital theodolite lines up perpendicularly to the center of the traverse cap, use the optical plummet located at the side of the instrument to look through and verify that the circular rings are on the center of the circular traverse cap. Next, open the battery door located on the side of the theodolite and insert the 2 C batteries located in the case, paying close attention to the positive and negative polarities. Finally, to complete the instrument setup, record the height of the instrument by using either the rod or a tape measure to measure the height of the instrument from the ground up to the gray line located on the side of the instrument as demonstrated. Record this value in the field book, in this case 4.80 feet. It is a value that we will refer to again as we complete this portion of our survey. For your reference, here's a look at point A, followed by point C. We will be turning the angle to the right to form angle ABC. We are now ready to begin surveying. To begin, the instrument operator removes the lens cap if they have not done so already and presses the red on button to activate the digital theodolite. Then the instrument operator sights the scope on a rod at point A, focusing specifically on the HI. Once the scope is very nearly sighted on the HI at the rod at point A, the instrument operator will then rotate the horizontal and vertical angle locking dials on the instrument to hold the angle. Fine adjustments may be made by rotating the dials immediately behind the locking knobs. Once the instrument has been carefully focused on the HI and the horizontal and vertical angles have been finely adjusted and locked, the operator will then press the zero set button on the instrument twice to zero out the horizontal angle. Next, the instrument operator looks through the scope and observes the upper and lower stadia readings and records those values into the field book. The upper stadia reading minus the lower stadia reading is your S value for point A. Also record the vertical angle shown on the instrument. Next, we will proceed to turn the angle to the right by unlocking the horizontal and vertical locks and then rotating the scope to be directed towards the rod at point B. At point B, we will once again focus the scope directly on the HI. Once the scope is focused on the HI, rotate the horizontal and vertical locks and use the fine adjustment knobs as necessary to zero in specifically on the HI as best as possible. Proceed to write in the field book the horizontal and vertical angle readings provided by the instrument. This will be your first unplunged horizontal angle. Next, proceed to place a hold on the horizontal angle by pressing the play-pause button on the instrument twice. Then, the instrument person should look through the scope and note the upper and lower stadia readings, and then have the recorder note them in the field book. Next, we will proceed to unlock the vertical angle lock and then rotate the scope 180 degrees so as to plunge the scope, and then we will unlock the horizontal angle lock and rotate the instrument so that the front of the scope is now pointed towards point A. Once the rod person has returned to point A, the instrument person may proceed to fine-tune the instrument back on the HI. Notice that the instrument controls are now facing away from you. Now proceed to rotate the horizontal and vertical angle locks, and then proceed to read the upper and lower stadia readings, as well as the vertical angle off the instrument, and record in the field book as a secondary measurement at point A. The objective now is to turn the angle to the right a second time. So, we will now have to unlock the horizontal angle by pressing the play-pause button once on the front of the instrument. Now that the horizontal angle reading of the instrument is active, we will proceed to turn the horizontal angle a second time by turning the instrument to look at the HI. The effect of this is that the instrument will now report approximately double the horizontal angle reading as was previously reported before for this same angle. Once the instrument is fully sighted in on the HI, the vertical angle reported should be approximately the same as before. Proceed to lock the instrument and record the horizontal, vertical angles, as well as the upper and lower stadia readings at point B. Remember, this is a plunged horizontal angle. To further reduce error, the survey team may turn this angle a third time, a fourth time, plunging the angle alternatingly just as we did between the first and second angle. This should always be done in pairs so that there is an even number of angle turns. Bear in mind also that once the instrument has turned 360 degrees, it will revert back to 0, so you may have to add multiples of 360 onto your horizontal angle to ascertain the correct angle reading. This completes the process for angle A, B, C. Continue on for each subsequent angle on your traverse polygon. Once the team is done with the instrument, place the lens cap back on the scope and remove the batteries. Gently remove the instrument from the tripod and return to the case. Remove the tripod from the ground, collapsing it, and picking up any trash that you may have accumulated in the field. It is now time to start the calculations.
So yung next instrument natin is yung planimeter. So according to American Mathematical Society, planimeter is a tabletop instrument for measuring areas, usually the areas of irregular regions on map or photograph. It is a mathematical instrument for directly measuring the area bounded by an irregular curve and hence the value of definite integral. So yung planimeter, madalas natin siya makikita kapag sa mga movies muna. Madalas natin siya makikita sa mga movies, lalo na kapag kumukuha ng mga treasure. Ginagamit yung planimeter para masukat doon sa map kung nasa ang part na ba sila ng region, nung map na yon, nung place na yon, di ba? So, in real life, makikita natin yung planimeter, ginagamit yan kadalasan ng mga structural engineers para masukat din yung graphical footprints ng bahay or ng building na ginagawa rin na asikaso nila. So, ito. Applications of planimeter. Planimeter is used as a mathematical instrument. It is used for the purpose of measuring and calculating area of a plane figure. It is also used in the building trade to calculate areas of large floors. A planimeter can be used to measure the area of irregular shapes by tracing an outline or perimeter, which then translates into a flat shape, often a rectangle. The area of traced outline is multiplied by the length of the outer edge or diameter to obtain a measure of the surface area. And lastly, the planimeter is also used in manufacturing industry to measure objects in factories. So, ayun, as NE naman, in real world, magagamit natin yung planimeter sa mga manufacturing industry wherein hindi na natin kailangan sukatin yung large object. Kailangan na lang natin siya i-scale into a small piece of paper. I-drawing natin siya by graphical method. Then, masusukat na natin siya by using of planimeter. So, what are the benefits of planimeter? The main benefit of planimeter is that it facilitates measuring the area of any shape in matter of seconds. So, ayun nga, as I said earlier, hindi na natin kailangan sukatin yung mga malalaking devices, malalaking components in actual. Kundi, gagawin na lang natin siya sa papel by a graphical method and by using the planimeter. Since these devices are electronic components, they can measure and display very accurate results in a convenience that cannot be matched by manual methods. So dahil nga electronics na rin siya, malilas na natin yung discrepancy, malilas na yung errors, kasi yun na mismo yung magsosolve ng gusto nating sukat. So para ma-understand natin paano ba gamitin yung planimeter, here's a short video.
Hi everybody, I want to show you how to use the planimeter in case you need to come in and use this on your own and I'm not here to help you. So you'll come in and ask one of the department faculty members how to use the equipment or where the equipment is and they'll give it to you. Please make sure that you use it in one of the classrooms or here in our office at the table. You are not allowed to take this off campus. This needs to be used on campus only. So the first thing that you're going to want to do when you use the planimeter is turn it on. You'll see the on button right here, okay? And then you're going to want to check your units. So you'll see that in this case, I'm already in good shape because I'm in inches, feet, and acres, but this button right here that says meters to feet will toggle you between metric and English units. So you can click this and toggle between metric and English units. And then you can click the unit button and you'll see the little tick mark moving up and down and you can change between inches, square feet, and acres. Now, the unit that you choose has to be the starting unit of the scale of your drawing. So for this exercise, our drawing is at a scale of 1 inch equals 30 feet. So I have to start the planimeter at on inches because my drawing starts on inches. We also need to set the scale of the planimeter. So the scale of this drawing is 1 inch equals 30 feet, but the planimeter cannot convert between inches and feet. So you have to make the scale 1 inch equals so many inches. It has to stay in the same units throughout for the planimeter to work. So in this case, since the scale of my drawing is 1 inch equals 30 feet, that's also equal to 1 inch equals 360 inches because there are 12 inches in a foot. So I'm going to type in 360 and then hit scale. And now you'll know that the scale is in the planimeter because you'll see it say scale in the top left corner of the display. Finally, you're going to want to set up the planimeter so that everything is perpendicular and you're going to start your readings so that you can go clockwise around the shape that you're trying to measure. And you want to set it up so that the wheels are perpendicular and everything is lined up. You're about at the midpoint on the left-hand side of the shape and that you can trace in a clockwise direction. If you try to trace in a different direction, you're going to get a wrong answer. Okay? So once everything's lined up, you'll see that there's a little bullseye inside the magnifying glass. It's an orange circle with a little orange dot. That orange dot is what you're going to trace along the line of the shape that you're trying to measure. So I have everything lined up. I'm ready to go. I'm just going to push start. Now I can start tracing my shape. I'm going to hold on to the black circle only at the top of the measuring ring, and I'm going to carefully trace my shape so that I can measure my area. Now, I'm not doing a very good job here. I'm being a little sloppy, so do not use the answer that I get because it's not really correct, and you can't really see it anyway. But note that the answer that you've been given is in square inches. You are supposed to provide your answer in square feet and acres. So you need to make sure that you convert to square feet and acres to complete this assignment. Also, please note that if you are doing this for real in the field, you should take 3 readings and take the average of those 3 readings to get a correct answer. All right, good luck using the planimeter.
So that's it for our group. Again, we are group 4. Thank you and have a great day.